Good evening, guys. Am I audible?
Yes, sir.
So, what was the last concept we saw?
Capacitance of a parallel plate capacitor.
Yeah. So, this is what we saw. Capacitance of a parallel plate capacitor came out to be epsilon naught times A divided by D. And the important points I told you to make a note of this. C depends on the medium between the plates, and it depends on the area of cross section between the plates and the distance of separation between the plates. Right?
Yes, sir.
No. And so we are going to see capacitance of a capacitor with dielectric between the plates. Okay. So if I take a parallel plate capacitor like this, positive sign, negative sign. If I place a dielectric in between them, right? If I place a dielectric of dielectric constant, let me say K, or actually it is called as kappa. Okay, K-A-P-P-A, it's a Greek letter. As of now, we can call it as K also. But one thing to be remembered is kappa is defined as the ratio of epsilon by epsilon naught. So epsilon is a permittivity of any medium, epsilon naught is a permittivity of free space. Okay. And this dielectric is completely filled between the plates of the capacitor. Okay, I'll take another scenario. Let's say the distance between the plates of the capacitor is T. Sorry, D. And let's say the thickness of the capacitor is T. That is, the thickness of the dielectric slab is T. I'm sorry, I repeated. The distance between the plates of the capacitor is D, and the thickness of the dielectric slab is taken to be T. Then how much will this distance be? The remaining distance is going to be D minus T. So what I'm trying to tell you here is, if I keep my hands like this, between them, there is a slab of thickness T, and the remaining part is air medium. And the remaining part is going to be air medium, whose permittivity is epsilon naught. Now, what will happen is, due to this positive and the negative charge, there will be an electric field generated in the rightward direction. Okay. So, there is a potential drop across the capacitor, which is broken into two parts. What are they? One is, like, see, the potential between the capacitor, between the positive and the negative plate. If I say the potential is V, then that V can be divided into two parts, that is V1 and V2. V1 and V2, where V is written as E into D, or I'll put it like this. Potential is equal to electric field multiplied with distance of separation. See, this is coming because we know that E is equal to minus dV by dr. Yesterday I told you E is equal to minus dV by dr. So you can take that minus sign and write it as V by D. So take it to the other side. What is going to be the potential drop across the capacitor? So V will be equal to, what is the value of V1? V1 will be equal to electric field across the first plate multiplied with the thickness of the plate, plus V2 is going to be electric field across the second part multiplied with the thickness of that part, that is D minus T. Am I clear with this first region, the second region? So the total potential drop across the capacitor is equal to the potential drop across the dielectric plus the potential drop across the remaining medium. So what is going to be the value of E1? E1 will be E naught divided by kappa multiplied with T, plus E2 is going to be E naught into D minus T. So what is E naught? It is sigma divided by epsilon naught. So sigma divided by epsilon naught, but that is already multiplied with kappa. So sigma divided by kappa into epsilon naught into T plus sigma divided by epsilon naught into D minus T. This is going to be the value of V.
Sir, will E2 not be E naught by K?
It is air medium, no?
Okay, sir. Okay.
For air medium, it is just E naught. For E1, it is E naught by K. Why I wrote E naught by K is when I explained the dielectric concept, right? I wrote it here, see, E divided by K. Okay, let me call this as equation number 1. And C will be equal to the total charge divided by the total potential. So what is the total charge that is present on the conductors? It is going to be sigma into A divided by the total potential is going to be sigma is taken out, T divided by kappa into epsilon naught plus D minus T divided by epsilon naught. So sigma and sigma will get cancelled. So C will be equal to, I can take the epsilon naught also outside. Then the epsilon naught will go to the numerator and multiplied with A. Epsilon naught into A divided by, you will be left out with D minus T plus T divided by kappa. Now this is going to be the capacitance when it is filled with a dielectric of thickness T. So when the plates of the capacitors is completely filled with air, it is going to be epsilon naught A divided by D. That is the one we saw yesterday. Right? If it is filled with a dielectric slab of thickness T, then it is going to be epsilon naught A divided by D minus T plus T divided by kappa. T by kappa is a separate term. I hope it is clear. So make a note of this.
Okay, sir.
Let me know once you're done.
1 minute, sir.
Yeah.
Completed.
So make a note of this formula. Let's solve a problem based on this. So it comes under the concept of effect of dielectric on a capacitor. This problem. So 2.8. A slab of material of dielectric constant K has the same area as the plates of a parallel plate capacitor, right? But has a thickness of 3D by 4. So what is the thickness of it? It is 3D divided by 4, and its dielectric constant is K. How is the capacitance change when the slab is inserted between the plates? So what is going to be the new value of capacitance? It is going to be epsilon naught A divided by D minus T plus T divided by kappa, right? So C dash will be equal to epsilon naught A divided by D minus, what is the value of T? It is 3D by 4 plus what is T by K?
3D by 4K.
Very good. 3D by 4K. So when you take LCM, right, D minus 3D by 4 is going to be D by 4. So C dash will be equal to epsilon naught A divided by D by 4 plus 3D by 4K. So take out the D by 4, and then when you solve it, right, that 4K will go to the numerator. So it is 4K times epsilon naught A divided by D into K plus 3. But what is epsilon naught A divided by D called as? That would have been the initial capacitance. Epsilon naught A by D is the initial capacitance when the capacitor is completely filled with air. So what will happen? C dash will be equal to 4K divided by K plus 3 times C naught. Are you able to understand?
Yes, sir.
Shall I proceed?
Yes, sir.
So the next concept that we are going to see is combination of capacitors. So when I talk about the combination of capacitors, we talk about two concepts. One is the capacitors in series, and obviously the second one is going to be capacitors in parallel. So when you talk about capacitors in series, right? So first let's talk about this series. We say that the capacitors are connected in series when the charge on each capacitor is the same. So if the charge on each capacitor is the same, then you can say that the capacitors are in series. Okay. So what will happen in the case of capacitors in series is the potential will get broken as V1, V2, yeah, it will get broken as V1, V2, V3, and V4. Sorry, it will be Vn, for instance. So the total potential that is supplied by the battery, what you will do is you will connect the capacitors in series and you will connect a battery here. When you connect the battery here, right? Let's say the potential supplied by the battery is V. Then this V is broken into multiple values like V1, V2, V3, plus so on till Vn. Okay, it is broken into V1, V2, V3, so on till Vn. If you see the value of V1, right, we know the relation that Q is equal to CV, which implies V is equal to Q by C. Accepted. So V1 will be written like this. V1 will be Q divided by C1 plus V2 will be Q divided by C2 plus V3 will be Q divided by C3 plus so on till it will be Q divided by Cn. Guys, am I clear?
Yes, sir.
Yes, sir.
So Q divided by C1 plus Q divided by C2 plus so on till Q divided by Cn. And this value will be equal to left hand side, you have the battery, right? So that you can write it as Q everywhere will get cancelled, as a result of which you'll be left out with 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus so on till 1 divided by Cn. So when capacitors are connected in series, the equivalent capacitance is measured like this: 1 by C1 plus 1 by C2 plus so on. 1 by C equivalent is 1 by C1 plus 1 by C2 plus so on till 1 divided by Cn. Am I clear, guys?
Yes, sir.
So next. The next concept is capacitors in parallel. So if I take this to be C1, C2, C3, right? So when you connect the capacitors in parallel, then unlike series, right? In series, what happens is the charge across each capacitor will be same, whereas in capacitors in parallel, the potential drop across each capacitor will be same. So here, if I take the potential drop to be V, here also it will be here, and here also it will be V. Okay. But what will happen to the charges is charges will be Q1, Q2, and Q3, so that the total charge supplied by the battery Q will be equal to Q1 plus Q2 plus Q3. So what is the value of Q? Q is equal to So if I replace this with the equivalent capacitance, if I replace it with C equivalent, then I'll get Q is equal to C equivalent into V, which will be equal to Q1 will be C1 into V, Q2 will be C2 into V, and Q3 will be C3 into V. So V will get cancelled, which implies C equivalent will be equal to C1 plus C2 plus C3. Right, this is going to be the equivalent capacitance when they are connected in parallel. I hope you're able to understand.
Yes, sir.
So what happens in the case of series? 1 by C equivalent will be equal to 1 by C1 plus 1 by C2 plus 1 by C3, so until 1 by Cn. What about parallel? C equivalent will be equal to C1 plus C2 plus C3 plus so until Cn. Clear?
Yes, sir.
So based on this, let's solve a problem and see. So there is a network of 4 10 microfarad capacitors which are connected to a 500 volts. Okay. As shown in the figure, determine the equivalent capacitance of the network. First, let's concentrate on that part. So if I take the first problem, right? Now tell me one thing. This is the place where battery is connected. This is the place where battery is connected. Right? So C1, so if you see C1, C2, and C3, how are they connected? They are in
Series, sir.
C1, C2, and C3 are in
Series, sir.
series. Correct. So for series, what are we supposed to do? 1 by C equivalent. I'll write it as 1 by CS. S stands for series, P stands for parallel. 1 by CS, can I write it as 1 by C1 plus 1 by C2 plus 1 by C3?
Yes, sir.
So 1 divided by CS will be equal to, in this case, C1, C2, and C3, everything have the same value. So can I write it as 3 divided by C1?
Yes, sir.
So by CS will be equal to 3 divided by C1 is 10 into 10 power minus 6. So CS will be equal to 10 into 10 power minus 6 divided by 3 microfarad. Am I clear? So the new diagram will look like this. I can replace the first 3 capacitors with CS, and the fourth one I'll take it as C4. Now, how are these two connected? How are they both connected? They both are in parallel. So I can take CP will be equal to CS plus C4. So what is the value of CS? It is 10 into 10 power. Okay, I'm sorry. Here it is 10 divided by 3 microfarad. It is going to be 10 by 3 plus 10. It is going to be 40 by 3 microfarad. So that is going to be the equivalent capacitance in this scenario. So how will the circuit look like? Develop 500. Yeah, 500 volt. And this would be 40 by 3 microfarad. So what is going to be the charge? Q will be equal to CV. So Q is equal to CV means 40 by 3 into 10 power minus 6 into V is 500. So it is 4 into 10 power minus 5 into 5 into 10 power 2 divided by 3. So how much is going to be? 20 into 10 power minus 3 divided by 3 or 2 into 10 power minus 2 divided by 3 coulomb. So this is the amount of charge that is supplied by the battery. Am I clear?
Yes, sir.
Yes. So the first part, equivalent capacitance of the network, we found it. It came out to be 40 by 3 microfarad. The charge on each capacitor, how much did the charge come to? That's what we need to find. We'll see how to do that. First, you can copy this part. So done. Is everyone done?
Yes, sir.
Okay. Now our job is to find what is the charge on each capacitor. So what is the total charge supplied by the battery? Can I take this to be the total charge supplied by the battery? It is going to be 20 divided by 3 microcoulomb. So out of the 20 by 3 microcoulomb, how much is going and sitting on C4? So it's very simple. So whenever you need to find the charge across each capacitor, right? What you need to do is you need to find the capacitor across which the battery is connected. So in this case, it is connected here. So what is going to be the charge on C4? Which I'll call it as Q4. Q4 will be equal to C4 into V4. What is the value of C4? C4 is 10. So 10 into 10 power minus 6 into V4 is 500. So how much is it going to be? It is going to be 5 microcoulomb. So among the 20, out of the 20 by 3 microcoulomb that is supplied by the battery, 5 microcoulomb is sitting on the top of C4. So how much will be the remaining charge? So how much will be the remaining charge? It is nothing but 20 by 3 minus 5. It is going to be 15 by 3 microcoulomb. So not 15 by 3, sorry, 5 by 3. It is going to be 5 by 3 microcoulomb. So that 5 by 3 microcoulomb which is remaining is what is going to sit on top of C1, C2 and C3. Don't make a mistake of again dividing it by 3. So remaining charge, whatever is there, that will sit on top of on top of C1, C2 and C3 because the charge across each capacitor is same. So when it comes to series, you will not add the charges. You will add the charges only in the case of parallel. Am I clear with what I'm saying?
Yes, sir.
Yes, sir.
So make a note of this point. Done.
Yes, sir.
Do that. Do this 2.6 and 2.7 and tell me the answer.
Sir, first one is 3.
First one is 3 here, correct?
Capacities.
So 3 picofarad.
Ah, yes.
What is the potential difference across each capacitor if the combination of 120 volt is connected across each. I mean 120 volt is connected across the combination.
Yes, sir.
How much is it?
1 minute, sir. I'll say.
By looking at the problem, you can actually guess it also. It's very simple. See, when you connect them in series, what will happen to the potential? Will it get divided or not?
Yes, divided.
Divided. No, all the three are of what capacitance?
Sir, I guess 40, sir.
That's the answer. But how to solve this? You got this 3. I hope everybody got this 3 picofarad.
Yes, sir.
Basically, 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So if I take this to be 120 volt, now what I'll do is I'll replace the 3 capacitors of 9 picofarad with 1 capacitor of 3 picofarad. What is going to be the charge on it? Q is equal to CV. So it is going to be 360 picocoulomb. Correct? Is that point clear? So the total
sir.
charge supplied by the battery is 360 picocoulomb. Now do the reverse analysis. This is C1, C2, and C3, across which you have connected a 120 volt battery. So how much will be the charge here? 360. Here the charge will be 360, and here also the charge will be 360. Am I right? So what are the capacitance here? 9, 9, and 9. So charge is this much, charge is this much, capacitance is this much. So what is going to be the potential? V is equal to Q by C. So 360 by 9 is 40. Here also 360 by 9 is 40. Here also 360 by 9 is 40. 1 minute. So clear with this? So it is going to be 40 volt across each capacitor. What about 2.7? 3 capacitors of capacitances 2 picofarad, 3 picofarad, and 4 picofarad are connected in parallel. What are the total capacitance of the combination? It's very simple. It's going to be 9 picofarad. Determine the charge on each capacitor if the combination is connected to a 100 volt supply. So since everything is connected in parallel, what will be common across each? What is common in a parallel combination?
Potential difference.
Potential, no. So here you know the potential, here you know the potential, here you know the potential. So what is going to happen to the charges? We know that Q is equal to CV. So charge on the first capacitor will be 2 into 10 power minus 12. Pico is 10 power minus 12 into 100. So that is going to be 2 into 10 power minus 10 coulomb. Q2 will be 3 into 10 power minus 10 coulomb, and Q3 will be 4 into 10 power minus 10 coulomb. Am I clear with this?
Yes, sir.
Okay. Next is do this 2.5. What is the answer? What's the answer? So first of all, tell me how to do. Not about concerned about calculation. Tell me how to solve. So capacitance is equal to epsilon naught A divided by D. When it is filled with air, it is epsilon naught A divided by D. What will be the capacitance if the distance between the plates is reduced by half? So C dash is equal to epsilon naught A divided by the distance between them is reduced by half, and the space between the plates is filled with the dielectric constant 6. So whenever the complete space is filled between the dielectric, the complete space between the capacitor is filled with dielectric, the capacitance will increase by a factor of k. Why is it so? Is C dash is equal to epsilon naught A divided by D minus T plus T by kappa. When T is equal to D, right, substitute it here, then C dash will be equal to epsilon naught A divided by D by K. So K will go to the numerator, it will become K times epsilon naught A divided by D. So capacitance will increase by a factor of K. Okay. So what you will do is 2K into epsilon naught A divided by D. So answer will be 12 into, what is the value of epsilon naught A divided by D? They have already given it. It is 8. So 12 into 8 is going to be 96. Means if the distance between the plates is decreased by half and the dielectric constant 6 is added, its capacitance will become 96 picofarad. Okay. Are you able to understand?
Yes, sir.
Okay, listen. So with this, actually we we have come to the end of this chapter. Okay.
Sir,
Energy, 1 minute, 1 minute. Yeah, energy stored in a capacitor is there. No, that one we don't have the derivation. We need to know only the value, which is half CV square. Okay. Yeah, Sai Kalyan, tell me what is your question?
sir, no doubt, sir. Can you show the solution for a 1 more minute? I'll just copy.
Yeah. This part, no.
Yes, sir.
Okay. Okay. See, we have almost come to the end of the chapter. So, two updates. One thing is, I'll not be able to take class tomorrow and on Monday. Okay. So, for these 2 days, I'm giving you a work where you need to go through the pre-recorded versions and ensure your notes is completed. From dielectrics onwards till the end of this chapter, till the energy stored in a capacitor, you need to go through the videos, take down notes and upload it in the app. Secondly, I'll be uploading an assignment at the end of this week also. That also should be completed. Okay. So on Tuesday, we'll be having the session in the academy. Again, from Tuesday, we'll be back to the in-person classes. So Tuesday, I'll take a class in the academy, and next Saturday, not this Saturday, the week following it, there'll be a test in this chapter. Is the point clear?
Yes, sir.
Tomorrow
Yes,
there is
sir.
no class. Tomorrow and Monday also there is no class. So you have to utilize these 2 days to ensure that you're going through the pre-recorded version and writing the notes properly. Prepare your notes and upload it. If it is not done, like how I informed previously in the class, do not come on do not come on Tuesday to the class. I'll not let you sit inside the class. Okay, that day I'll be solving more of problems. I'll be discussing a lot of questions from this chapter, and I'll help you with the assignment that I've given also. Is that clear? So you need to
Yes,
work
sir.
from your side on that. Okay. So that's the update. And yeah, I'll see you guys on Tuesday.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.